Again, my name is Alan Monaghan. I'm the Global Mission Coordinator for the Net Zero Industries mission, representing Australia as co-lead. I would like to welcome you all here to the latest in our webinar series. This webinar presented very proudly in collaboration with our sister mission, the Green Powered Future mission. What we'll be doing today is we'll be running through 2 keynote and 3 industry presentations, each approximately 10 minutes long, and then we'll be holding a question and answer panel for you to be able to address your questions on specific details from each of our speakers. What I'd like to do first is to give you a quick rundown on the agenda for today. You'll see that we'll have introductions from both myself and from the Green Powered Fusion mission. We'll be starting with a keynote presentation from Ricardo Saviano from the United Nations Industrial Development Organization. We'll also have a keynote presentation from Nick Salmon from the International Energy Agency, and then we have 3 industry-specific topics being given to us on our webinar topic today, which of course is electrifying Asia's hard-to-abate industries, providing clean power for a competitive net zero future. So we have Yi Yang from the Tianrun New Energy Company. We have Shane Miller from the Renewable Energy and the Future of Industrial Competitiveness from Meranti Green Steel, and we have Iji Ahia from the Kawasaki Gas Turbine Company of Europe. To start off, please, I'd like to give a quick introduction to those who haven't seen it of the Net Zero Industries mission. Of the 7 missions of Mission Innovation, Net Zero Industries targets the largest and hardest to abate industries of steel, cement, and chemicals and refining. Combined, they make up 25% of global greenhouse gas emissions, and it is the most complicated and expensive of the sectors to decarbonise. In the case of many of these applications, the technologies that are required to decarbonise the industries are not yet proven at scale. And so our efforts are very much addressed at how we can spotlight the demonstrations and the eventual viability of each of technologies, at least 3 full-scale technologies for each of the main sectors and each of the main technology pathways, such as electrification, carbon capture and storage solutions, digital solutions, etc., replacement of fuels, green hydrogen, etc., across each of those 3 industries. We want to be able to highlight both the industry and government developments that actually help enable and accelerate the adoption of those solutions in industry to actually help our industries and the world achieve their targets by 2030. If I can now, please, I'd like to introduce and hand over to our partner for this webinar. Can I please introduce Yaxuan Jiao from the Green Powered Future mission?
Yeah, thank you, Alan. And good day to everyone. So I'm Yaxuan Jiao from the Institute of Electrical Engineering, Chinese Academy of Science. And on behalf of the GPIFM co-leads, I would like to deliver a warm welcome to all of you. The Green Power Future mission actually aims to help power systems worldwide to integrate up to 100% variable renewable energy by year 2030. And we aims to keeping the systems cost effective, secure, and resilient. So today, together with our partners, the NIM, the Night Industry Mission, today we're focusing on the Asia's hard-to-abate sectors and explore clean power solutions for their low-cost transition. And as the hub of the global industry decarbonization, actually, as we all know, the Asia's steel, cement, and chemical industry actually underpin the regional economy. And in order to cut down the emissions without compromising the competitiveness and energy security, the clean energy electrification actually stands out as a very practical and scalable choice. And the renewables, flexible grids, and electric heating are gradually phasing out the fossil fuels. And as we all pretty agree that the green power is now stands to be pretty essential for those industries to achieve deep decarbonization. And thanks to the falling renewable cost and the improved grid industry, the industry electrification has been widely adapted worldwide. And with the strong investments, policy support, and clean power, we think will actually unlock pretty huge potentials across Asia countries. And by supporting the cutting of emission, the technology progress, and industry competitiveness on the path to net zero. So today we are very honored to have the speaker from UNIDO, IDDI, IEA, as well as experts and partners from Japan, Thailand, and China. So they will share cutting-edge technologies, market trends, and real-world cases, which I believe will bring us valuable thoughts. So let's fully exchange the ideas and learn from each other. So I think we will join hands to accelerate the process of the industry decarbonization across Asia energy sectors. And now I will hand over to Alan, and I think we could probably start our session. Thank you.
Thank you so much, Jiao. It is my absolute pleasure to introduce our first speaker for tonight. May I please introduce Ricardo Saviano. Ricardo is the Chief of the Energy System and Decarbonisation Unit at UNIDO, where he has held several roles focused on sustainable industrial development and environmental protection and gender equality. If I can hand over to you, please, Ricardo.
Thank you, Alan, and thank you, Zhao, for your kind invite to participate to this webinar. I'm trying to put forward my screen, right? I mean, we mocked it yesterday. Let me see if I can do it properly. And I will try to give you, for the next 10 minutes, a bit of a flavor on how UNIDO. I hope you see it, right? I take it as a yes. And yeah,
Perfect.
I will try to, thank you. I will try to just to drive you into the topic because I mean, clean electricity, and I would like to underline clean electricity is becoming a strategic industrial input. And actually Asia is playing an enormous role into that because of the, let's say, industrial growth and the supply chain and the future demand for materials and so on and so forth. I mean, Asia includes the largest and the smallest, let's say, economies in the world, and of course, the way the topic is implemented varies completely. However, there is a connection between trades and markets that may that is pushing also integration at the regional level. So as I say, as Alan mentioned, my name is Riccardo Savigliano. At UNIDO, I'm leading the energy systems and industry decarbonization unit. As said, why electrification is important, why industrial, let's say, growth is important, and why greening industrial applications is important is because industry represents 1/3 of global CO2 emissions, and almost 70% from that emissions comes from 4 industries, meaning cement, steel, chemicals, and aluminum. And that brings us to some considerations that could be, let's say, focusing on sectorial, and then let me get back to that in a bit later stage of the presentation. However, what I want to say is that in East Asia, actually 40% of the emissions are actually coming from primary energy for industrial applications. And the power in industry in China itself accounts from 75 or to 87% of the total consumption. So it's the trend is that the requirements for energy into industry is growing because the material demand is also growing. At UNIDO, we are looking into services and we support to member states in their efforts towards net zero transition in industrial applications. And here you can see the main 5 pillars or the building blocks of the services and the strategies that we are proposing. And of course, electrification is one of them, but cannot be just considered alone. Electrification could be a competitiveness, let's say, lever if combined, of course, with energy efficiency and low carbon energy supply. So that has to be considered very well. That electrification alone is not a lever for decarbonisation, but this is something that for which let's say there is a clear common understanding. So when it comes to transition, we may need to start looking and start trying to understand a bit more in terms of the expansion of clean technologies and the markets of those technologies. So mature markets are already large and cost-driven when it comes to energy supply. However, it's different for net zero materials and products. So here in this slide, you see that there is a huge discrepancy between the supply and the demand, and where technologies investments are looking into. And in between, there is what we look at UNIDO is the market creation architecture. And here we are not talking about technologies. Here we are not about talking about let's say assets. We are talking about definitions. We are talking about standards. We are talking about measures that would allow defining what green products is, and to support investments towards green transition, including electrification. When it comes to electrification, I wanted to say that this webinar is coming at a very let's say crucial period, where the entire let's say global debate is looking into actually the electrification as a area of focus on climate action. So in the next few months, leading to COP31, there are going to be debates and discussions on how to concretely move commitments on electrification, and of course the energy demand in the industrial sector is going to be one of the key, let's say, sectors and areas of concentration. Why? That is because 70% of the use of energy in industry is for heat. And there was a recent study published by the Oxford University saying that 95% of technologies may be available already to replace this demand with electrified technologies. However, only 50% may have business cases today. So, and those business cases are usually for lower temperature, where heat pumps and heat recovery solutions could be easily implemented. And then also electric boilers and heat storage solution could be of interest for industries because they proved to have business cases. One of the points that is extremely relevant in this discussion, however, is not only the technology and the side of the let's say the application, but is how the grid could support that. And it's important to highlight that demand will grow for the next years and the years ahead. And then there is a need for additional energy supply. However, what is important is that to know that it's estimated that more than 2.5 terawatt of renewable already produced are stuck in grid queues. And that is something that is going to increase more the moment, again, the supply of energy, let's say, is increasing. Another point, what I was mentioning at the beginning, that we have to be careful about, is to consider the electrification as a part of a let's say block of intervention put together with energy and also efficiency. And to measure the impact of electrification on the carbon embedded in products, we need to understand how to measure for those let's say specific technologies and applications. Here, let me refer to a sister kind of initiative under the Clean Energy Ministerial, which is the Industry Deep Decarbonisation Initiative, which is looking exactly into definitions of how green steel or near zero steel and near zero cement could be, let's say, identified. And it talks about it supports basically countries to set up policies for green public procurement for countries to be off-takers, so public initiatives, public infrastructures, and so on, to be the first one, let's say, procuring for near zero products. That's a very important. So here, we are, as I said before, we are not talking about technologies only, but all measures to allow those technologies to be, let's say, accounted and properly measured. Different sectors. Here you have the four sectors that, the three sectors that I mentioned before, consuming 70% of the energy in industry. So all of them require a different approach. What is in common for every one of those industrial applications is that there is not one single technology pathway, but the common enabler are clean power, standard, infrastructure, and I would say also efficiency. So this is what, and then I'm about to conclude. 2 more slides. You need what we do in this complex landscape. We try to help governments to set up the right environments and then to send the right let's say signals to the market in terms of commitment. We support on technical and financial to create technical and financial readiness, and we try to support the market development. Let me refer to one declaration, the Belém Declaration on green industrialization. If you are interested, again, it's a gathering that is not only for government, but is also for private sector and academia and civil society to join. It talks about how greening industrial applications could actually be the lever for development. In Asia, of course, as I said, can lead the net zero industry, and electrification could be definitely a strategy to be extremely can be extremely effective from a technical point of view, but also for transforming markets. The question is not longer whether hard-to-abate industry should electrify, but the question is how fast Asia can align clean power, flexible infrastructure, standards, and investable demand. With that, I conclude, and I thank you for your attention. Alan, back to you.
Thank you so much for that, Ricardo. It was an enormous amount to take in there, and we were very fortunate to have you here presenting for us today. Regrettably, Ricardo isn't able to stay for the whole session, but please, if you would still like to ask questions, hopefully a member of his team will be available to answer those questions during the Q&A at the end. But again, thank you, Ricardo, for joining us today. We are honoured by your presence and appreciate your inputs. Our next speaker on keynote number 2 is Nick Salmon from the IEA. Nick is an energy modeller in the demand sectors unit at the IEA, where he's worked since 2024. He is responsible for modelling and analysis of the industry sector, with a particular focus on heavy industrial sectors, including cement and chemicals, as part of the World Energy Outlook. It's my pleasure to introduce you to Nick, please.
Well, good morning or good evening, everyone, depending on what time zone you're in, and thanks for the introduction, Alan. I'm conscious that we're quite short on time, so I'm going to share my screen and we can get started. You can see that I think you're seeing the wrong screen. Let me swap that around. Okay. Let's get started. My name is Nick, as Alan said, and today I'm going to be talking about industrial transformation in the age of electricity from the perspective of the International Energy Agency. So just to dive in and give a little bit of background as to who exactly we are. The International Energy Agency is based in Paris. We're an intergovernmental organization that was created in 1974 in response to the first oil shocks in the Middle East, with the goal of helping countries collaborate to respond to similar oil shocks. And as you can imagine, we've been very busy given the recent crises in energy markets. But our mandate has expanded since we were founded over 50 years ago, and we now support countries in their understanding of energy markets across all fuels, and also in understanding how they might transition their economies to help achieve their decarbonisation pathways. So before we look in too much detail at industry in Asia specifically, I wanted to give a little bit of context about what we call at the IEA the age of electricity. So at the IEA, we don't produce energy forecasts, but we do scenario-based analysis that helps understand the impact of policies on the way the energy sector will evolve. And what I'm showing on the screen is 2 of those scenarios that we modelled in our World Energy Outlook last year: the current policy scenario, the CPS, and the stated policy scenario, the STEPS. Now, both of these scenarios are rooted in historical trends and deep policy analysis of what different countries around the world intend to do with their energy sector. And there's some marginal differences between the scenarios as to how ambitious they are with respect to climate change. But actually on this side, we see quite similar trajectories in the context of electricity. And that's why we call the period that we're about to enter into the age of electricity, because we see very rapid electricity demand growth on the horizon, moving away from focused in China, where most electricity demand growth happened in the last decade, to occurring also in advanced economies and emerging markets and developing economies outside of China, particularly in India and Southeast Asia. To put this growth in context, the total global electricity demand today is only about 28,000 terawatt hours. So expecting 10,000 terawatt hours of growth over the next decade is a very significant addition to global electricity demand. Where is that electricity demand happening? It depends a little bit on the exact scenario that you're looking at, but I want to draw your attention to, firstly, the role of advanced manufacturing. And the reason that I say this is because we're talking about industry today, and it's important to recognize that industry is electrifying in the context of many other new electric technologies entering the market. Now, that's driven on the supply side by particularly low-cost solar and other variable renewables that are becoming increasingly available. And it's driven on the demand side by new electric technologies that are becoming more important. And there's another feature, which is the importance of electrification when it comes to energy security. So those offer an opportunity for industrial decarbonisation via electrification, but they also create challenges. So Ricardo spoke in the last presentation about the difficulties of connecting to the grid. And we have to acknowledge that industry is trying to electrify at the same time as a lot of other additional electricity demand growth. And that means that some of the challenges, like connecting to the grid, can become a lot more significant. Lastly, on this slide, I just want to emphasize that even though we see significant electricity demand growth, we're still a long way off achieving the goals of the IEA's net zero emissions by 2050 scenario, which sees even faster electricity demand growth. Ricardo mentioned the COP31 pledge, or the suggested pledge, to achieve 35% electrification by 2035. And that's a goal that's achieved in the net zero emissions scenario. So we see a lot of work to get to that very high rate of electrification. And industry needs to contribute to that. It's about 30% electrified today. In the net zero emissions scenario by 2050, it reaches 50% electrification, which is a significant step up. So what does electricity demand growth look like today in the stated policy scenario? What I've got on the slide here is a bit of a deeper dive into different industrial subsectors and where we're seeing additional electricity demand growth over time. So on the y-axis, you can see the share of electricity within those subsectors, so how much of their energy comes from electricity. And on the x-axis, you can see the amount of electricity those sectors are consuming. And the key point that I want us to take away from this slide is that in the stated policy scenario, these lines are quite flat, which is to say, we're not really anticipating a great deal of electrification of industry over the next 10 years. Rather, we'll see electricity demand growth coming from the fact that sectors which already consume a lot of electricity, like the machinery subsector, are growing in activity much more quickly than other sectors which are less electrified, say the cement sector, which isn't doing very much on the bottom left-hand corner of the screen. So when we're talking about electrification, we really need to alter this trend and start to see these lines move vertically. So how can we make that happen? Firstly, let's take a look at different regions around the world, and I want to zoom in on non-energy intensive industry. I know the focus for today is energy intensive industry, but these non-energy intensive industries are typically much easier to electrify, and so we need to make sure that the enabling conditions are right for non-energy intensive industries, or energy intensive industries will also really struggle. So these non-energy intensive industries have different rates of electrification around the world. The key point to note here is that some parts of Asia are very much world leaders already in the electrification of non-energy intensive industry, and that's Japan and Korea, who've had a long time advantage, and China, which has seen a significant increase in the share of electrification over the last decade. Now, to some extent, this is because Japan, Korea, and China are leaders when it comes to making sure that they're using electric technologies where they're available, as opposed to using, in particular, fossil fuels to perform mechanical work. But To some extent, the reason Japan, Korea, and China are leaders is because the specific subsectors that their economies focus on tend to be more electrified already. So we saw on the last slide the role of the machinery subsector, and that plays a very strong role in Japan and Korea. So to some extent, they're technology leaders, but to some extent, the structure of their economy is giving them an apparent advantage. The other takeaway that we can take from the right-hand side of this slide is the importance of prices. So really, the European Union should be more electrified than it is because it's a natural gas importer. It largely relies on importing also oil and also coal, which tells us that it would be better if it was more electrified because electricity tends to be made domestically. But it remains languishing alongside the rest of the world in its electrification rate. And a key contributor here is the fact that the prices in the EU are wrong. The natural gas price is too low relative to the electricity price, which means even technologies like heat pumps, which use electricity much more efficiently than other technologies, still struggle to be competitive in some parts of the EU, although they are increasingly competitive. On the other hand, we see that the price ratios, particularly in China, are much more favorable towards electricity. And that's how you can start to see the pickup in the electrification rate over time. And that's a really important thing to think about. We need to make sure that the electricity price is right in order to drive electrification in industry. So that was non-energy intensive industries. Let's take a look at energy intensive industries. So what I've got on the slide is the share of technologies, novel technologies, that are deployed in our net zero emissions scenario by 2050. And we've plotted that against their technology readiness level. And the bigger bubbles need more electricity to be able to operate. We at the IEA consider hydrogen-based technologies, if the hydrogen is produced on-site by electricity, to be electrification. It's indirect electrification. And what we can see is that to achieve direct electrification, we need quite a lot of research and development. And even to achieve indirect electrification, we need quite a lot of research and development to get these technologies from where they are right now at a TRL of 6 up to a TRL of 9. And that's a really big challenge because these technologies in that range are in what we call the valley of death for innovation because they need quite large investments, but there's still a high degree of uncertainty as to whether or not these technologies will play out. But it's also important to note that we've been talking about research and development for quite a long time, and achieving outcomes like the net zero emissions scenario requires quite radical action. So we need to look for quicker ways to bring these technologies to market. So Ricardo talked about the importance of standards, and that's certainly key for hydrogen-based DRI. That's the big yellow dot, because that's an important way to help low emissions and near zero emissions steel producers attract a green premium for their products. But we can also reframe the way that we think about competitiveness of these technologies. So if we think about ammonia, the target for most countries has typically been to have very low priced ammonia because it's used as an input for fertilizers and that needs to be cheap to sustain the food sector. But we've seen in the recent crisis in the Middle East that has typically caused us to rely on imported ammonia from the Middle East. And that's a particularly big problem in Asia. So the benefit of electrolytic ammonia is, even though it might be more expensive in the short term, it's produced domestically and is therefore more reliable. And so we need to reframe some of these industrial products as key for our energy security, as well as something that we need to produce at very low prices. And that can help bring technologies to the market, and that can make things move on a little bit more quickly. So, having seen the last slide, I think that it would be easy to think, wow, we need a tremendous amount of electricity demand growth. We need a tremendous amount of research and development processes in order to achieve these outcomes. But just to finish up, I want to draw your attention to something that happened 50 years ago after the 1970s energy crises. And there were three things that happened. The first is we saw a very fast addition in the following decade of nuclear electricity that was considered a more stable and more domestic source of electricity. We saw very rapid improvement in the efficiencies of new cars, over 50% in the United States in a decade, which is quite remarkable. And we saw a significant upswing over the course of the 1970s into these research and development budgets that we need to achieve the net zero emissions scenario that I talked about on the last slide. So even though the challenge before us is quite significant, I guess that it's important that we remember that the energy system is not static. We've seen two major crises in the last few years, and those crises can precipitate quite rapid change. And it's important that governments and industry use this opportunity to some extent to drive rapid change in the energy sector. So that can be a way that we can achieve faster electrification. And I know that I've gone over time, so I'm going to pause there. Thanks so much for listening.
No worries. Thank you so much, Nick. And there was an enormous amount of information that was brought into that presentation. I think I'm going to watch back the video to make sure I've caught it all. Our next speaker, just a quick reminder for everyone, please, if you'd like to put your questions into the chat, we will be getting to those during the Q&A session at the end. We won't be holding specific questions after each speaker. We'll do them in a block panel after all 5 speakers have presented. But speaking of next 5 speakers, if I can please, our next speaker is Eiji Ahira. Eiji is the European representative of the Japan Hydrogen Association, and he's the head of hydrogen business development for the Kawasaki Gas Turbine for Europe, which is an affiliate company of Kawasaki Heavy Industries. He's responsible for developing, executing, and coordinating KHI's global hydrogen business. It is my pleasure to hand over to you, please, Eiji.
Okay, can you hear me?
We can perfectly, and your presentation is showing.
Oh, thank you, Oren, for the introduction. My name is Eiji Ahira, and I'm working for the Kawasaki Heavy Industries, and actually working for the Kawasaki Gas Turbine in Europe within the Frankfurt. I'm very happy to introduce our hydrogen activities. You know, Japan, a leading country that promotes hydrogen. Why hydrogen? Hydrogen can contribute to decarbonization in all the sector, especially the hard-to-abate sector, including the heavy duty transport or on heavy industry, or etc. Also, the hydrogen contribute to the other agenda like energy security through the diversified energy sources, as well as economic growth. So the many in the Japanese industry and joining in this field. Right, and this is our Kawasaki hydrogen technologies overviews. And Kawasaki, and thanks to the support by Japanese government, we are committed to make the hydrogen the center of the future businesses. Based on the current existing businesses, we expanded and our business to the hydrogen, from the hydrogen production, storage, and the transport and utilization. And for storage and transport, we focus on the liquid hydrogen. I told you later. Utilization, we have many an item like the fuel cell train and hydrogen motorcycle, gas turbine, gas engines, and not just limited to the illustration. And we make it kind of realize our technologies. Because there is still big challenges like cost issues or any other issues, but we make and our technology with to the reliability and realities. Okay, top left, and what is hydrogen motorcycles, hydrogen engine motorcycles, and top right and top center and in the bottom, and hydrogen combustion and hydrogen engines and power generation, the hydrogen gas turbine. And top right in the world for us, liquid hydrogen tankers, and also they were working for the hydrogen compressor for pipeline distribution or hydrogen engine for the maritime application. All right, and from this slide, I will talk about our recent priority and activity on hydrogen, and we are now strongly working to develop the global supply chain. Because Japan, yes, and we promote the expanding the low carbon energy, like including the renewables and hydrogen, ammonia, etc. Unfortunately, in Japan, we have very much limited to space to such kind of the to low carbon energies. So why we somehow need to import and the kind of the low carbon energy vectors. The challenge is in how to concentrate and this and hydrogen for long distance transportation. There's the many and choices like ammonia, methanol, organic chemical hydride, but Kawasaki choosing the liquid and the hydrogen because we have the much experience about cryogenic technology through the liquefied natural gases. So the main Chinese items are liquefaction, the storage and handling, and the liquid hydrogen carriers. So liquefaction, we just behind in the other huge in industry, but we started to develop the high efficient liquefaction and systems. So today, I will talk about a snapshot of the current and storage and handling and liquid hydrogen transport. This is show all the our step-by-step approaches for onshore liquid hydrogen storage. And at top left, we already developed and tested in a pilot scale the liquid hydrogen onshore tank. That's which is to 2,500 cubic meter in size. Also, we can store the 150 tons of the hydrogen. But it's just at the pilot scale, but we move to the next phases, which is 20 times bigger and compared to the pilot scales. We started this kind of activity from the 2021. We make, complete and this kind of project by 2030. And following that, and we plan to further scaling gap in the futures. All right, and this is our largest and pilot scale, our pilot scale and onshore storage tanks. This requested and scale type of the onshore tank. As I mentioned, that we can store the 250 tons of hydrogen can be stored. And the big challenge is and how to keep the boil rate, low boil rate. We tested and we found it at the boil rate in the 0.06% per day. It's quite low. We also testing the and large scale loading and unloading and liquid hydrogen systems. Our next step is and also the business scale liquid to develop the business scale liquid hydrogen terminal. And we may study the some of the and liquid hydrogen equipment fusion and this kind of system. Demo terminal may develop by 2030. And this is the kind of image location of our demo terminal, and they're just close to the Tokyo near the Haneda Airport, Tokyo Airport. Right? And sorry. And this is the kind of the industry area. Once we develop the liquid hydrogen storage, we can deliver the liquid hydrogen to the nearest industry site. Right, and another challenge is the liquid hydrogen carrier ship. Also take the step-by-step approaches from the small one, the pilot one, that's and just 75 ton liquid hydrogen carrier can be carried. And after demonstration, we tested the technologies and we to move to the next phases, the medium scale liquid hydrogen tanker we developed by the 2030s. And finally, our ultimate goal is almost the same scale. It's liquid natural gas, 160 and 1,000 cubic meter ton. We can also carry almost the 10,000 tons. And this is the world's first liquid hydrogen tanker carrier. The name is and Swiss Frontier. We just put a liquid hydrogen tank in the head of our carrier ships. And so testing the especially also boil rate, we find that boil rate and 0.3% per day, even just to in real in operation. Here, you see that we already tested here and 3 demonstration journey between Japan and Australia, and we find it and to certified and our liquid hydrogen technology is going to be useful. And as I mentioned that we are moving to the next phase. This next phase I mean scaling up to realize and grow our hydrogen supply chain. So those were our current recent liquid hydrogen activities. And thank you very much for your attention.
Excellent. Thank you so much for that summary, E.G. My mind is still absolutely blown by the fact that you're working on a hydrogen motorcycle. As I said, questions, please. Please put them into the chat there, and we'll be getting those at the Q&A session next. But it is my pleasure to present our next speaker. If I can introduce, please, Yi Yang. Yi Yang is the head of energy and carbon solutions for the Tianjin New Energy Company in China. Yi Yang is the assistant general manager and head of energy and carbon solutions at Tianjin New Energy, which is a subsidiary of the Goldwind Group. Her current work centres on load-side business, wind solar storage integration, and carbon electricity synergy. Over to you, please, Yi Yang.
Hi, can you hear me clearly?
We can, and your slides are showing perfectly.
Okay. Good morning, good afternoon, and good evening, everyone. I'm Yi Yang, Assistant General Manager and Head of Energy Carbon Solutions at Tianjin New Energy, a subsidiary of Goldwind Group. Today, I will talk about how digitalization and integrated energy services can help us to build zero carbon parks and break through the bottlenecks. Okay, let me first quickly introduce our company, Goldwind. We are a global clean energy company. Our core business includes the wind turbines, energy storage, energy development, and energy services. We operate in North America, South America, Europe, Asia, Africa, and Oceania. We have strong R&D and a global strategy. Our goal is to help customers to use sustainable and affordable energy. And this is the 5th year for us to achieve global carbon neutral in Scope 1 and Scope 2. At the same time, our main upstream suppliers also achieve 100% green electricity in manufacturing our product because of our green supply chain requirement. That's why we really have a deep practice in carbon zero. Okay, the next one is about the policy opportunities and the challenges. As you know, in 2015, the Paris Agreement set a target for the global, and in 2020, the China government announced the dual carbon goals. By 2030, the carbon dioxide will be peak, and by 2060, we will achieve the carbon neutral. And this year, there is a latest and practical guidance, the dual carbon performance, which is now linked to the evaluation of province. This is a great enforcement, and there are 5 binding indicators you can see on screen. And if you fail one, you'll fail the whole year. And also in Europe, we know the policies like CBAM, the battery regulation, and the ESPR are pushing very hard. And all of these policies brings us the opportunities and challenges. Okay, first for the challenges, we know we have unclear baseline, the difficult enforcement, and slow and costly certification. Much of the energy and carbon emissions data is now still recorded manually by hand. The paper documents are easily lost, and even when we saved it in computer, they almost stay on local hard drives. This means the data is not real time or secure. And the certification is also very slow. Usually takes about 2 to 3 months and costs a huge amount of money, effort, and time. But we also have many opportunities. The first, the policies accelerated the industry the electrification, like replace the fossil fuel equipment with electric alternatives, and this cuts emissions and energy costs. Secondly, the strong global competitiveness, and now almost all of the countries and companies are purchasing the low carbon products to meet the CBAM standards and avoid the carbon tariffs and gain the pricing power. And the last one is the new power model. The green direct connections like VPP and green hydrogen are growing very fast. So how do we solve these problems? Goldwind has built a net zero solution for a new power system. We optimize and reconstruct the source, grid, storage, and load to help industries and parks separate the economic growth from carbon emissions. Our solutions works on three sides. The first side is the energy supply side. We maximize the renewable energy used inside the park. We increase the green power consumptions to over 50%. This includes the wind, solar, and storage. And the second one is the energy consumption side. We improve the energy efficiency across industries. This can reduce energy consumption by 5% to 15%. The third one is the trading side. We use the green electricity trading and the carbon emissions trading, including like the CCER, CER, and all of this to help achieve the carbon neutrality. But the real breakthrough is our digital platform. We have two main tools, the Oasis Carbon Management Platform and the Oasis Energy Management Platform. Let me explain the complete pathway. Normally, a zero carbon park needs a long time to establish, like from planning to design to construct to operation and lastly certify. As a professional renewable supplier, our pre-services actually starts from the planning. Not only just the hardware, but also software. We also have a detailed survey to our clients. For example, like we will ask the clients what's the emission source, what's the organization, and what's the emission goals, or the low carbon products, and help the clients to finish the initialization to make sure that the platform really help them to solve the problems. And this is what we do on the platform. As you can see, this is the architecture of our platform. And the main, and we provide the one-stop application from measure to calculate to replace, reduce, offset, and the certifying. I will explain one by one. First, the measure. We clarify the total energy consumption of the park. We define the physical boundaries and we connect all the devices. You can see the data is from bottom from the Internet of Things like devices, meters, and the manufacturing systems like MES, SAP, or financial systems like CRP. All of the data will be collected from the bottom of the system, and this can make sure that the data is a real-time data. The second, we are going to calculate all the data. Our platform collects data and we calculate carbon emissions from product level to enterprise level and finally to the area level. By now, we already accumulate many modelings in our platform. And next step, we will help our clients to replace the fossil energy with green electricity, like the direct green power target is over 50 and the clean energy consumption target is over 90%. We also use waste heat, cooling, and pressure with a utilization rate over 50%. And we also have to help our clients to reduce the carbon emissions. Like from we are going to use the AI management, including the machine learning, the knowledge graph, and the time series forecasting. We optimize the energy dispatch and our forecasting models to predict like the wind power, solar power load, and the electricity prices to make sure our clients cost less. And we also help them to offset for remaining emissions. We use carbon offset like CCER or CER to trade the carbon emission. And finally, the certify. We coordinate with the third-party authorities like SGS, like the BV, to help the clients to we With this digital system, we can aggregate and dispatch energy, forecast the wind and solar power, monitor the load, and execute the market transaction. But this is not just the theory. We also have results. Let me quickly show you some case studies. So you can see the first client is Xinjiang Jinxuechi. This is a lubricant manufacturer, a kind of oil. So for this client, they have like 20 to 30% of their products are exported, and they urgently need the low carbon products to enter the new energy vehicle market. So we help them to get 4 product carbon footprint certifications and verified by SGS, and now they can access that incremental park. The last case is about ourselves. This is Goldwind's own net zero smart park. You can see this is China's first carbon neutral park. It has a 2.3 milliwatt PV system and 2 wind turbines. One is 2.3 milliwatt and the other one is 2.5 milliwatt. And we also have a cold storage system of 3,000 RTH with peak loading about 3,500 kilowatt. And all of these are linked into our microgrid. And in 2025, this park receives the NGEU, the global level certification under the EU's Next Generation EU initiative. And it is now a global benchmark for green parks. And if possible, we warmly invite our online audience to come and experience our park. So the last is as Goldwind, we provide a complete solution from measurement to certification, powered by artificial intelligence, IoT, and real time. We help parks to reduce costs, meet the regulations, and again the competitive advantage. And again, we warmly welcome you to come and experience our park. That's all. Thank you.
That was an excellent presentation. Thank you so much, Yi Young. I never fail to be both surprised and impressed by what has been achieved in China in recent years and decades. And I look forward to actually finding out what kind of advantages AI is going to be able to bring when we start linking measurement systems, control systems, and simulation systems together. So that's a very interesting space for us to keep watching. We've already been to Japan. We've heard from China. And next we're going to be hearing from Thailand, albeit with a very Australian accent. Our next speaker is Shane Miller. He's the Senior Manager of Constructions for Meranti Green Steel in Thailand. Shane, as I said, is a Senior Manager of Construction and Project Management for Meranti Green Steel, where he supports the development and delivery of the company's large-scale green steel and infrastructure projects. Can I please welcome to the stage Shane Miller?
Hello, everyone. Welcome from Australia. It's nice to meet you all. Meranti Green Steel are a Singapore-based company that has operations in Oman and Thailand, and is supported by essentially an engineering team from the east coast of Australia. Today, we're showing you how renewables and electrification make a lower carbon content steel, and we'll speak specifically about the Oman and the Thailand, pardon me, the Thailand projects. So, why is steel hard to decarbonize? The conventional route for steel is for the from the blast furnace to the operation furnace, the BOF. It uses coking steel as both the energy source and the chemical reductant. Removing the coal isn't simply a fuel switch. It requires a different method of iron making. as coal is both the fuel and the chemical input in conventional steelmaking. The process Meranti are using is a lower carbon route, combining a direct reduction furnace and then an electric arc furnace, so that the DRI will be in Oman and the electric arc furnace will be located in Thailand. The two big shifts to cleaner iron making and electrification. The direct reduced iron replaces the coal-based iron making using natural gas or hydrogen. In fact, the technology at the moment, and with the availability of the hydrogen, it looks like in Oman we're going to be starting up with predominantly natural gas. Then we'll move to 15% hydrogen, and as the process goes on, we're looking at getting up to around about 80% hydrogen in the mix of the reductant. The HBI, as it stands, is stable and transportable, which is significant because other methods of transporting iron are not quite as stable, and they can combust in transit. The electric arc furnace then in Thailand melts the HBI, and it has the ability to increase its green value by using scrap steel with the electricity and not a fossil fuel as a combination. It's not working. In Oman makes the iron. It provides a pretty unique opportunity for investment with green energy, because there's plenty of sun in Oman, and in this particular area of Oman, on the seaboard there's for about 8 months of the year there's very prevalent and strong winds, which means cheap power, which can make the green hydrogen, which is to be utilised in the DRI process. And as mentioned earlier, the DRI process replaces the coal-based iron making. I mentioned about the starting on natural gas and then ramping up onto hydrogen. The output being HBI, which is hot briquetted iron, is solar dense and it's easy to transport. We're looking at having this online completely by 2030. There's a number of other developments around the area, and it's the technology's proven, and will be the first of a base in Oman. Our first plan, and there's a number of plants planned. The first plant will be 2.5 megatons per annum. From Oman, we transport the HBI by ship to Thailand. The Thailand turns the HBI and then the scrap into green steel. The scrap isn't all just locally sourced. It's sourced from around the world. We do have to sort the scrap into specific grades, because obviously that will affect, because it all gets mixed up, will affect the final output, and requires different amounts of energy to melt it. But the HBI and the scrap all combined in the one electric arc furnace, and so it's using clean electricity. Thailand also locks in renewables, so whilst we may not directly have wind or solar or hydro providing energy for this plant, we will have offsets in the system to ensure we have green net zero fuel. Across the this is the value chain of a cross-border model, and I mentioned it earlier. We're making iron where energy is its strongest, and we make the steel closer to the demand. So obviously, I mentioned earlier about the favourable conditions in Oman to make electricity. to produce the hydrogen and to make the HBI product. And then we move through the shipment and transport as bulk cargoes. And then to Rayong in Thailand, we're making the steel in the AF and the furnaces there. And obviously from Southeast Asia, the port there is much more central to dispatching to Asian and Australian markets. The quality of the steel coming out of there is suitable for automotive uses. Automotive, as you may be aware, is particularly stringent on the properties of the steel, and as are the appliance industries. What changes in this system? It's not just a fuel swap, but it requires a redesign. So the conventional route is the blast furnace to the basic oxygen furnace, as uses the coal. It's a single integrated site and produces a vast amount of CO2 per ton of steel. The new way with the DRI process, the direct reduced iron, and the electric arc furnace process, using renewables and a hydrogen pathway, which we discussed before, and the progression from 15% hydrogen up to about 80% hydrogen in the gas mix. Significantly reduces the CO2 production from day one, and it mentions there the calculation is more than 70% reduction of CO2 from the very beginning of the process to the end. So this is just a final slide. Renewables power the transition, electrification changes the process, and at Meranti Green Steel, we're connecting both across regions of the world. Our catch cry there is redefining limits and enabling futures.
Excellent. Thank you so much for that, Shane. What we're going to do now is move to a Q&A panel. So if I can please invite all of our speakers to turn your cameras on. If you have any last-minute questions, throw them into the chats. I've got a few that have been presented here for me, and I'll jump to those in a second. I believe we also have someone replacing Ricardo from, and that is Mr. Philip Werkel. So welcome, Philip. Thank you for stepping in. If there are any questions on the UNIDO presentation, Philip will be here graciously to be able to help answer those as well. The first question I have, I'll jump back to the starting presentations, and I'll ask a question, please, to Nick. And it's a little bit political. Obviously, we've been looking at a large amount of disruption in the Middle East in the last 3 months. How has that crisis impacted, and how will it continue to impact the industrial electrification in Asia, in your opinion?
Well, that's a big question. Certainly, the way that the executive director of the International Energy Agency put it a few weeks ago is that the crisis in the Middle East signaled the death knell for the fossil fuel industry in the long term, because he was making the point that countries will increasingly look to domestic alternatives to powering their key energy sectors, of which industry is one. And electricity is a much more domestic alternative than imported fossil fuels. And Asia is particularly vulnerable to that context because it's one of the biggest importers of energy. And we've seen really strong impacts across India, across Sri Lanka, across parts of Asia, which have reduced to a 4-day working week as a consequence of the energy crisis. And I think it's important to remember that we've seen progress this week, which might mean that oil will start to flow again through the Strait of Hormuz. But this is the second energy crisis that we've had in 5 years. And that means that countries will take notice of the situation, and they're likely to want to seek out more secure alternatives. Having said all of that, industry, as I alluded to in my presentation, sometimes industry can be harder to electrify than other sectors. So if we compare to, say, the transport sector, where you get a 4 to 5 times efficiency dividend when you use electricity to power a car as opposed to using oil, countries are likely to jump at those easier opportunities before they jump to industry electrification. And because it's only been a couple of months since the crisis, we haven't necessarily seen a lot of motion yet on individual plants moving towards electrification. The stronger effects have been in demand reduction, where we've seen, for instance, in India, ammonia plants being curtailed or shut down as a consequence of the crisis. So I guess to summarize my answer to the question, we've yet to see a clear pickup in electricity use, but there is some evidence that the technologies which use electricity are picking up, and electric vehicles is a really good example of that. And it's likely to signal a long-term policy change that governments might be pursuing, particularly in Asia, which could bode really well for electrification of industry.
Excellent. Thank you for that, Nick. Never waste a crisis, as I think someone famously once said. For the next question I have here, I'm going to address it, please, to EG. EG, we saw some wonderful examples there of what Kawasaki's working on. Where do you believe specifically hydrogen is going to contribute the most in the decarbonisation of the hard-to-abate sectors? Are there some specific examples there from Japan that you'd like to raise?
Yes, as I told you, hydrogen can contribute to the decarbonization hard-to-abate sectors. In Japan, other colleague mentioned that one of the big issues, big one is the steel making, and also the chemical industry. Also, the big impact to using the hydrogen for decarbonization. On the other thing, in Japan, we also working for the other industry and to introducing the hydrogen and for example, and to the industry that they need the high temperature heats, they need to install using the boilers. Now, we already developed the hydrogen boilers to install the some of the industries. We also not Kawasaki. I talk about the general Japanese and the other industry company and working for the hydrogen furnaces. The hydrogen furnace using for glass industries or ceramics or any other kind of. And that was that kind of the technology to still and the demonstration, but and we plan to install and expand this kind of equipment combined with internal and the hydrogen supply chain to identify how it works and for the decarbonization at the balance and the industry sector.
Thank you for that, EG. Much appreciated. The next question I have here is for Yang. Yang, please, with the CBAM program entering its substantive phase this year and the EU importers required to purchase CBAM certificates for specific products starting next year, how can the Oasis Energy and Carbon platform help both importers and manufacturers manage and reduce this new cost pressure through digitalization?
Okay, thank you for your question. This is a very practical question, and we think the core challenge is twofold: the data credibility and the cost efficiency. On the data credibility, the CBAM requires accurate, verifiable emissions data reported to the European Union authorities. And for our platform, we use the blockchain technology as its core trust layer. Once the emission data is recorded on the chain, it becomes tamper-proof, which is significantly enhance the reliability of the reported figures. Additionally, our system supports invoice uploading and OCR recognition, which is especially valuable for categories where the automatic metering is not yet available, such as certain process-related emissions like the fossil fuel, like the coal. And on the cost efficiency, our platform integrates the electricity carbon coordination to help manufacturers to optimize their energy mix in real time. For example, during the low price grade period, on-site storage systems are triggered to charge. During the peak price hours, storage energy is dispatched to reduce the grid. In green power direct connection scenarios, the system smartly increase the renewable energy utilization and minimize the fossil fuel consumption when the wind or solar output is available. The result is a clean energy profile and a lower energy bill, helping the manufacturers stay compliant with the CBAM results without scarifying the competitiveness. Thank you.
Excellent. Yeah, thank you for that answer. One thing for sure, we can never deny economics and the impact it's going to have on everything we try and do. Next question I have, please, is for Shane. And at this stage, I don't have a question for Philip on my queue list here, so I'm going to hit you with one, Philip. Hopefully it won't be too earnest, but get your mind ready. I'll be coming to you next. But my question for you, Shane, you mentioned the availability of green energy there, but isn't that it? Why have you started this process in Oman?
Thanks for the question, Alan. Oman has numerous benefits for the industry. Firstly, geographically, it's fairly central between both Europe and Asia, which are both big markets. There is increasing opportunities for HBI utilization in Europe in particular, as they're shutting down their existing BOFs, blast furnaces and basic oxygen furnaces, due to the high cost of the energy and also with the pollution that goes with it. Previous or other speakers have mentioned CBAM. That's a large factor in the production of steel. Also in Oman, there's a cost-effective supply of natural gas that's available. I do believe at the moment, though, it's got a limited lifetime, but that's yet to be fully determined. And the H2 projects are developing in Oman at a rather rapid rate, and there's numerous other steel companies also looking to develop HBI and DRI plants in Oman due to the H2 supply that's there. Finally, for Oman, probably the most significant thing at the moment is that the location in Oman where we're building is it's got a natural deep water port, and it's far enough away from any narrow shipping channels that require specific negotiation or management with any other slightly volatile neighbours.
Excellent. My grandfather once told me, don't read a newspaper underwater. Highlights the fact, choose the best environment to guarantee your success, and you'll have a much easier journey. The question I'm going to put onto you, Philip, without notice, is UNIDO is huge. It has an enormous impact and potential for impact. Where do you think its biggest impact is going to be in actually assisting industrial decarbonisation? Is it in the supply and demand modelling or in some other area?
Thank you so much for the question. Also, thank you for having me. Let me put it like this. UNIDO, with its mandate to assist its member states in emerging markets and developing economies, we see that our biggest role in convening a technology transfer from, let's say, the global north to the global south to make technologies accessible in emerging markets or developing economies is where UNIDO's impact can really thrive. We do believe in the importance of energy modeling for sure. When we talk about demand creation and demand shifting, I think what is important for us to also highlight is creating the enabling environment for the demand of electricity for green products. This goes beyond what Ricardo mentioned of the green public procurement into clean power purchase agreements, for example. I think this creation of an enabling environment together with the incredible solutions that we heard from today from our colleagues from the private sector is how UNIDO can actually lift up the technologies to lead to electrification of industries, especially in the heavy emitting industries.
Excellent. Thank you, Philip. We have time for, I believe, 2 more questions before we do our wrap up and close. The first question, please, for Mr. Ahira, regarding the hydrogen gas turbines and motors developed by your organisation, are they designed to operate on 100% hydrogen, or do they currently require blended fuels?
Okay, and thank you for the question. And our idea is using the existing to equipment and changing, just minimize and change the investment. Anyway, for the gas turbine, we just changing the to combustors, and we can use the both liquefied natural gas and the hydrogen. It means we can change the percentage of the hydrogen from 0% to the 100%. Or engines also, and we can change the hydrogen percentage, but engine a little bit big challenges. So, and stationary and engine for the stationary power generation, we can just 30% and hydrogen in co-combustion. Maybe in the future we make it in 100%. And motorcycle just demonstration. It not make sense in using the dual fuel. So just focusing only on hydrogen combustion for the motorcycle engines. Thank you very much.
I'm glad you threw in that last one. I'm very interested in the hydrogen motorcycle as an interesting experiment. What might be our last question before we do our wrap up? So apologies that we haven't got to everything, but a quick and easy one for Shane, please. There's a question there of how cost competitive can you be in regarding getting the HBI arriving in Thailand?
Great question. The cost competitiveness comes about the price of natural gas is known. The price of the supply of hydrogen at the moment is debatable. It's anywhere from we're being told between sort of $5 and $8 per kilogram, which is when you're talking with a 40% change in the price of the raw product, it can increase things significantly. The shipping costs are standard for, not say standard, depends on the size of the vessel, obviously, when moving stuff between the Middle East and Asia, but they're essentially a fixed cost. So I will take that question under advisement and provide a more definitive answer about that, rather than just provide you with some background to it. I should qualify that by also saying that my speciality is construction, not operations and OPEX costs. But I'll get back to you about those questions.
Excellent. Thank you for that, Shane. That is all the time we have available for questions, but what we'd like to do now is just do a quick wrap up. If I could please invite our co-host of this event to come back on in a second, please. That's Yashwen Jiao, to give a quick thank you from the Green Powered Future Mission. I'll just start by saying an absolute thank you on behalf of NIM to all of our speakers, to Ricardo and Philip from UNIDO, Nick from the IEA, E.G. Yi Yang, and Shane from industry. We've benefited from your insights, and we truly appreciate you joining us and supporting us in our webinar program. I'd like to thank all of our attendees today, and I noticed some of my friends in the audience and some of our colleagues from Mission Innovation. Shout out to Luciano from the Green Hydrogen Mission. And I'd like to thank both the teams of NIM and Green Powered Futures Mission for actually putting in all of the effort to make these webinars possible and to operate as seamlessly as they do. I'll give a quick summary at the end of how you can get access, but if I can, please, let's just hand over. Has the camera? Yes, it has. Excellent. Xiao, if I could hand to you.
Yeah, thank you, Alan. So first of all, actually, I would like to thank you for your wonderful sharing during the session. And again, as part of the co-host team, I'm very honored to express my sincere gratitude to all the speakers just mentioned by Alan for your wonderful sharing and candid discussions just now. So again, we very much look forward to proceed further collaborations to advance the industrial green electrification across Asia and also the world. Thank you again so much for attending today's webinar, and we are looking forward to keep contacts with you closely in the future. Thank you.
Thank you so much, Xiao. If I can draw everyone's attention, please, in the chat, our team there, Oksana, has put in some links. What you'll find is there's a survey, because we always appreciate feedback on where we'll be taking our programs, what we can do to improve. But we also have links not just to the LinkedIn pages for the Net Zero Industries mission, but also for the Green Powered Future mission. And what you'll find is that in the coming weeks, there will actually be a copy of the video of this presentation put onto the website and onto our YouTube channel, and you'll also see links and updates coming in social media on LinkedIn. We'll be advising both on our website and on LinkedIn of future webinar programs, so please tune in, follow, and find out where our next speakers and topics are going to be. But with that, thank you all again. I hope you have a very productive day, week, year, whether it be your day, your evening, or your very early morning if you're joining us from the United States at the moment. With that, we'll close today's session, and I look forward to seeing you all on our next webinar. Thank you very much.